Okay, I'll try and be quick. So my name is Dario Teixeira, and I also intend to conquer the world. But anyway, this conversation will not be about that. I will just give you a brief overview, just to give you the proper context. Most of the talk will be about OCaml stuff, and please research your questions to the OCaml things. The other stuff we can talk offline about them. So I will just give you a brief overview about OCaml and the web and why I think the language is ideally suited for this domain. And then I will talk to you about Lambdoc. Lambdoc is a library I developed for my own purposes, but which I think can be very useful for some of you. Anyway, what is the Enlighten project? The idea is to build a platform for, could be for citizens journalism, could be for scientific journals, and the idea is to take user-contributed content to the next level. I think we're all familiar with lots of sites where people can submit links, but I wanted to take this model and go beyond links. So where people could submit their own articles, with rich content, with images, with tables, complex, really complex documents. Another objective is to make these web communities resilient and scalable. And this is something that so far most people have resorted to very ad hoc solutions. And this results in websites that succumb sooner or later to moderation problems. They get dominated by trolls eventually. And my idea is to tackle this problem in a more scientific way and hopefully make a website that can scale to an indefinite size with that, always maintaining a good level of quality. And of course, I want to build everything based on a strong foundation, and that's where OCaml and Ocsigen come in. Okay, OCaml and the web, is it a marriage made in heaven? I would like to think so. Because the Ocsigen project, I'm not affiliated with the Ocsigen project, by the way, so any mistakes I say here are my own responsibility. But anyway, it brings the safety and all the fancy features that we enjoy in OCaml also to back-end web programming. And I reckon that pretty soon also to the front end. I think there will be a demonstration about that later on. So OCaml's type safety can be extended also into the communication with the database backends. There's projects like PG-OCaml by Richard Jones that do this. Even though as soon as you start digging a bit deeper, you'll realize that there's still a bit of impedance mismatch in the way that we OCaml people look at data types and the way that, for example, PostgreSQL people look at data types. So that's a bit of a problem. One question, this is a bit tangential to my talk, but I think it's important to emphasize it. It's a perennial issue on the CAML list, and it has also come up more than once in the Ocsigen list, which has to do with the non-concurrent garbage collector in OCaml. Many people feel that this makes OCaml unsuitable for the web domain, because the web domain is by, in essence, a domain where you have plenty of users and there's lots of concurrency, and you feel that you want to deal with things in a very threaded manner. And my point is that this is actually an irrelevant problem. Ocsigen relies on a green thread model. It uses the LWT library. So basically you write your code in a cooperative fashion using a monadic style. And this gives you maximum performance per core. Because the fact that you have, for example, multiple threads means that every time there's a context switch, okay, that's expensive at the operating system level. And using this green thread model, you don't have to incur those penalties. So by core, this gives you the maximum performance. And then you have the problem, yes, but my computer has 8 cores. How do I take advantage of those? And yes, the web is highly concurrent, but it's a domain that's trivially concurrent, in the sense that the multiprocess model, instead of the multi-threaded model, is applicable and can be put to effect with relative simplicity. Oh. Okay, yeah, I think it's still working. I'll just give you an example of how you can easily have multiple servers without any kind of interaction between them, so they're all independent. And you can have a dispatcher that takes care of your multi-process situation. So here you have a bunch of Ocsigen servers, you have multiple users, and you have a dispatcher in the middle. One of the users makes a request. I want some page. Initially, you can see that there's no cookies inside This would be where the cookies would be. The dispatcher says that there are no... It's the first time the user makes this request. So it chooses one of the servers, one of the Ocsigen servers at random, or it chooses one which is not so busy at the moment, and sends it the request. The server replies. It sets a cookie. Ocsigen always uses some cookie to identify requests. This cookie is sent to the request. The reply is sent to the dispatcher, which then forwards it to the user, and adding a cookie, another special cookie that tells which Ocsigen server was the originator. The next time the same user makes another request, it sends both cookies, of course, both the Helium cookie and the dispatcher cookie. And then the dispatcher can then just remove the extraneous cookie and forward the request to the same server. So as you can see, the dispatcher doesn't need to keep any state about which Ocsigen server is associated with each user, so it's completely stateless. And you have a very simple mechanism that allows you to scale your website to as large as you want. Okay, the Lambdoc library. So, as I mentioned, I have this fancy idea about users submitting their own content, rich content, stories and articles and everything. And why? I mean, the thing is, we can, in principle, just get users to submit HTML, with the whole story and the whole article. And yeah, sure, there's the little problem with security, but otherwise we can trust our users to provide us with sensible documents, right? I mean, they all have good taste and this will not be a problem. Well, perhaps it will be a problem. So, what is Lambdoc then? It's a library that offers support for complex and semantically rich documents in web applications, and specifically Ocsigen applications. So it was built from scratch with the Ocsigen integration in mind. It distinguishes between two very broad classes of documents. So you have manuscripts, which are longer documents that may have internal references. For example, you can have a bibliography or a list of notes or, really all kinds of internal references. And these are useful, for example, for main articles. And then you also have compositions, which are limited. They cannot have internal references. And these are useful, for example, for comments to the main story. The library includes already parsers for 3 distinct markups, Lambtech, LambHTML, and Lamblight, and I will talk about each of these later. And it includes support for outputting values of Ocsigen's xhtml.m module. Just a bit about the architecture. It's more or less what you would expect. So you have the several parsers. There's a common AST that then gets compiled into the internal data type. And from this you can write into a variety of different outputs. At the moment only this one is implemented, but it's in my plans to also implement a LaTeX writer. Because again, we have all these rich documents with rich semantics, because if you want to print them, you can have a very nice looking document via LaTeX. Elements. You have pretty much all elements that are commonly found, that typographers will commonly use. The library implements them all. If you find something else that is not implemented and you would like it to be part of the language, please tell me so, and I will gladly add it. Again, if it makes sense for web application. On the basic, at the highest level, the language makes a distinction between block level elements and inline level elements. If you're familiar with HTML, it's pretty much the same distinction. So a block level element will typically occupy the whole width. A block can be, for example, in that case, there's a heading, which is a block. Another block is a paragraph, and here is another block. Inside blocks, in this case a paragraph, there are several inline elements. So in this case, all the text is the inline element. Other elements, it's pretty much the things you would expect. So for example, lists, numbered and unnumbered, and description lists, and they can be nested ad nauseum. You have quotation blocks, which can also be nested ad nauseum. Source code, of course, with syntax highlighting automatically, you just have to say, look, here's a bunch of code, it's OCaml, please format it nicely, and it will. Pull quotes, another of the things that typographers like a lot. Box outs, you can define your own box outs, your own theorems as well. And really, there are many other features that can be defined. Subpages, which are useful, for example, if you have child documents. And obviously figures, which can be numbered and referenced from anywhere in the document. Tables, another thing that you would expect it to be there. About the markups, the first one is Lambda. Now, the syntax is inspired by LaTeX, but it doesn't have some of the hairy stuff. I think at this point some of you might be wondering, like, why yet another markup? Why not just use LaTeX? And the reason is that LaTeX, I mean, I have a love-hate relationship with LaTeX. I like the concept, I like the results, but as soon as you start digging a bit deeper, you're faced with the messiness. I mean, there's a lot of inconsistencies between different packages, and since the markup itself is tuned to the print domain, where documents can be printed, there's lots of extraneous stuff which only had complication if you're thinking about publishing on the web. And my idea was that if the syntax is similar enough and you use the same names for the elements, then existing LaTeX users will grok Lambda immediately. So basically the only thing you will need is a small cheat sheet, like telling you the equivalences, and as you'll see, a LaTeX user can look at the code and understand immediately what is going on here. Being simpler than LaTeX also has the advantage that new users will be able to learn it a lot faster and a lot easier than they would with LaTeX. So, and there's already a very extensive manual, so please consult it. It describes pretty much everything about this particular markup and about the Lambdoc library. So here in the example, you can see most of the syntax is very similar to LaTeX. I tried to impose a bit of consistency. For example, every time you declare a label, that's declared with between the square brackets. So every time a comment accepts a label, it's always declared the same way. The same way if you have an ordering, or if you're declaring extra parameters. This is one thing that LaTeX can be a bit inconsistent. Another of the markups is Lamblight. So it's a lightweight syntax, similar to Markdown or WikiCreole. It's in fact largely compatible with WikiCreole. It just adds a few extra things, and that's why it's not called LambCreole. It does not cover the full range of the library features, but it's at the same time it's very useful for comments, because you can just for example with specifiers for bold text and emphasized text and a link and a lightweight notation for lists or quotations, you can go a long way. When you're writing a comment, this tends to be more than enough. Finally, there's Lambda HTML, which is an XML-based markup, largely compatible with XHTML. Personally, I think it's a bit crazy for people to manually type XML-based markups, but some people actually like it. It's mostly in place because there are lots of tools that export XML. There are even browser plugins that allow you to define your documents in what you see is what you get way, and then they export HTML. So obviously I needed to have that support too. Okay, just a bit now about the implementation. One of my primary concerns was to have a library where pathological documents would be forbidden at the type level. For example, imagine a document that has an abstract inside an abstract, or box outs inside box outs, or quotations inside pull quotes. There are lots of combinations which a flexible structure would allow, but I don't want to allow that. So I want to impose some constraints on the kind of documents that people will submit. And it would be very nice if these constraints would be enforced even really at the type system level. In the case of inline elements, remember these are the elements that, for example, form a paragraph. You have here the whole list of them. This null list, by the way, is the type of non-empty lists. So it's basically just a pair of an element plus the rest. Here, the description does not include any constraints. Presently, the constraints are being enforced via phantom types on the constructors. But how to do this? One approach, the approach used by the XHTML module from Ocsigen, is to have, in this case, for example, this is the A element, the one that creates a link. It's a triple. They include, first of all, the range of attributes which are accepted, then the range of children which are accepted, and then finally, the type of the attribute itself. And you will notice that attributes, that links are not part of the accepted list of children. This means that this enforces that constraint, and the link cannot be the parent of another link, which is a very sensible constraint to have in any kind of language. There is, however, one problem with this. I call it the grandchild problem, though I'm sure there are other names for it. In this case, imagine then that I declare a link with only one child, which is also a link. The type system will complain. This violates the constraints enforced by the phantom types, and the type system will complain. But imagine that you then put a link whose child consists only of a span, whose child of the span is an attribute. Well, it will be happily accepted. But this is something that I don't want to be accepted. This should be wrong. So my approach here, it's also based on phantom types, but a bit more. In this case, it's still relatively simple. So I have, first of all, a constraint on the types of compositions and manuscripts, because it's useful to make that distinction between the two different kinds of documents in the library. And the second is about elements can be either links or non-links. And this way I make sure that no matter the degree of ancestry, I can never have a link that's the ancestor of another link. For block elements, I'm not going to go very far into the block elements. The list is quite long. I don't even list them all here. But you have similar problems. In fact, you have much more complex problems, because the number of constraints is extremely high. And also, the grandchild problem also occurs with block elements. For example, I don't want box outs to be the parents of other box outs. However, I want box outs to be valid children of lists. And I want lists to be valid children of box outs. So you can imagine, if I use the same approach as in the XHTML module, it would be possible for someone to declare a box out, and then declare a list, and inside the list declare a box out, thus kind of getting around my initial constraint. So my solution to this was, first of all, try to come up with a hierarchy of all the elements used in typography, and try to group elements which have similar properties into similar classes, and then to create a subtyping hierarchy. So for example, in this case, it's kind of difficult to see back there, but I'll walk you through. An embeddable block is a block that can occur in practically all situations. A quotable block excludes quotations, because quotes cannot appear in some circumstances. So for example, you can define in this case, a pull quote. A pull quote can consist of embeddable blocks, but not of quotable blocks. So this excludes some of those constraints. And by defining this hierarchy, it's possible to compress the number of required constraints into something that's actually manageable. This is the implementation. It's a bit hairy. I won't go into too many details about it. But basically, you can translate directly that hierarchy into phantom types, which are used to constrain the constructors for the blocks. Okay, just to finish, some of the features used in the language. The features are configurable at runtime. There's an accept deny default mechanism. It's similar to the one that's used by many Unix daemons. I'm sure you're familiar with it. So in that first example, imagine that you have, for your particular website, you don't want a certain user or a certain class of users to be able to use images for whatever reason. So you can just say that the feature image is part of the deny list. The default behavior is to accept, and you just call the parser with this argument. So you say, accept by default, accept anything that is part of that deny list. The dual situation is when you want to, by default, deny everything, but accept, for example, only features for plain text and paragraphs. So it's also possible to do that. Other feature, detailed error messages. This is very important when you're dealing with users, might not be terribly technical. So you have very detailed error messages with very nice, pretty printing. Other features, the language supports a very basic macro mechanism. Even though it was designed for using web applications, you can use it on the command line. If you have your own documents that you want to convert to HTML, like in this example. So you invoke the command line utility. It says that the markup is Lambda. It's 2xhtml. This is the source file. This is the output file, and it gets done. It has built-in serialization with using the SXLib. Native UTF-8 support, of course, which is like mandatory nowadays. And also some special integration with Ocsigen. Ocsigen users will be interested in this. It allows you to use the library in a cooperative fashion. Okay, the road to 1.0. It's currently at 0.82. The library is practically finished and is stable, so it's perfectly fine if you want to try it out and give me feedback. Before 1.0, I would like to incorporate that feedback. So if, for example, if one of you encounters a situation of a document that you feel is perfectly valid, but my constraints do not accept it, well then please let me know that I'm being overly constraining. I also need to generate the API doc. There's still a problem with OCaml doc when you're using module packs, which is kind of the barrier here. And otherwise, it also needs to be stress tested. More information. The library is available on the OCaml Forge, and the code is licensed under the GNU GPL v2, so it's free, it's open source. Play with it. Questions?
Well, just a curiosity, have you looked if on the Haskell half of the world they have similar problems, and maybe if their solution can be ported to our type system or not?
Well, Haskell, in terms of the constraints, well, the thing is, if OCaml had native support for GADTs, those constraints will be implemented that way. So Haskell does have that native support. Is that what you mean? Yeah, that indeed. I mean, at the moment, the implementation is it relies on phantom types, but it's only because the JDTs are not native to OCaml. But yes, ideally, these constraints are a good example of that requires a GADT.
Any other question? Everyone is hungry? Okay, thank you.